And speaking of Ben, he's going to be presenting our next mini presentation, which is around Allotrope Modeling Domains and potential opportunities for future expansion. As I mentioned before, Ben Wolford-Lim is our senior developer here at Allotrope and is going to be talking a little bit about some opportunities for expanding the different domains that we cover within Allotrope. Go ahead and take it away, Ben.
Sorry. Yeah, so from what we did previously to where we want to go in the future. So we had the request to basically explore sort of the space out the sort of the ontology and data model space outside Allotrope in the wider world, with a view to sort of see what really was out there in terms of an end-to-end laboratory workflow. We focused on about half a dozen different particular domains, materials, which of course is absolutely critical. You can't really do an experiment without a material to work on. The concept of experiments themselves, things like the recording of the information in the electronic lab notebook and that sort of domain. Processing equipment, which is really focused on the sort of the transformation of materials in a sort of a physical rather than a chemical sense. Things like mixers, grinders, things you tend to find more in a production facility rather than the next bucket, which are the analytical instruments, which has been a more traditional focus of Allotrope to date. The last two, of course, being results, which again are absolutely critical. There's not much point doing the experiments if you don't record the results afterwards. And the last one being control, actually the operation of these instruments. So this is just a quick table to sort of highlight the various ontologies and data model projects that we were able to identify from a fairly brief review of some of the major ontology collections out there, things like the Obo Foundry and BioPortal, as well as a general search and investigation with some of our partners about the efforts that they were aware of going in. So that's the table. I'm going to skip fairly quickly over it because I think more useful than the table is going to be the diagram we tried to put together to cover not only the coverage, the existence of these things, but also how well they covered these domains, the sort of the breadth of coverage and the depth of coverage that we felt they had from our sort of fairly light touch review. So in terms of the ontologies, you can see that the coverage is variable, I think is a fair way of putting it. In terms of the materials domain, there's two, I would say, major contenders. There's the chemical entities of biological interest, CHEBI ontology, which is something that Allotrope actually leverages reasonably heavily internally, as well as an IDMP ontology that's been put together by the Pistoia Alliance. Of course, AFO has some coverage of materials ourselves, beyond that, which we leverage from CHEBI directly, but I would say that it's a domain that's well served in a very narrow niche. All of them have fairly narrow fields of focus. Allotrope is perhaps a little broader, but even then, I wouldn't say we cover the space we certainly don't cover the space in a deep way as the other two ontologies do, but I wouldn't say we cover the entire breadth of material usage down from sort of the concept of the atom to all the way up to the big batches that you see that you produce and take samples from. We cover some of the field that needs to be covered, but there's certainly scope for improvement there. In terms of the experiments, the ELN usage and things like that, there are, I'd say, two major competitors there. There's the bioassay ontology and the ontology for biomedical investigations. One note that I would make on both the IDMP and the bioassay ontology is neither is particularly well BFO aligned. To the best of my knowledge, neither of them has been built with the basic formal ontology as a top level ontology, which means that reuse alongside other ontologies may be more challenging. Certainly ontologies in the biomedical space tend towards BFO as a top level ontology. Not to say it's impossible, but it certainly wouldn't be an easy thing out of the box unless mappings exist. I wasn't able to identify any in my initial review for that. So yeah, materials and experiments, there's definitely some scope. Processing equipment, as you can probably see, there is not a lot of depth of coverage, nor is there a lot of breadth of coverage. There are 3 ontologies that maybe touch on some of the content that's needed, AFO being one, the chemical process ontology PROCO by our friends from Merck and the University of Michigan being another, and the chemical methods ontology being a third. Between them, there's a reasonable amount of breadth of coverage, but I certainly wouldn't say that it's very deep, and there's potentially scope for opportunity there. Analytical instruments and results are I would say, the allotrope ontology's bread and butter, and you can see that reflected in the diagram there. We have good depth and pretty good breadth in both of those. Chemical methods ontology is another candidate for analytical instruments. It's probably not quite as deep, maybe a little broader than we are. And then there are a few technique-specific ontologies such as NMR, CV, and PSIMS out there that are very narrowly focused on single domain, NMR and MS being those examples. And of course, being narrowly focused, they're almost certainly going to be deeper in terms of coverage, but absolutely not broad enough to cover the overall domain. They are also variable as to whether they are BFO aligned or not. So again, reuse of those alongside other ontologies may be challenging depending on the choices made. In terms of results, you can see the AFO comes out pretty well there, but 2 other things for consideration are the information artifact ontology, IAO, and the software ontology, SWO. We actually leverage IAO fairly heavily internally as well, but both of those are very general purpose. Neither of them is really specific to a particular technique or domain. They're really about the framework of how to represent results, which is why they are fairly deep, but very, very narrow focus. And then finally, for control, we have a few terms in the ontology for AFO, but I wouldn't say we're particularly specialized about instrument control at the present day, and I wasn't able to identify particularly many others or any others that really had a significant proportion of control there. There may have been some technique-specific ontologies that could do a particular technique to some extent, but not enough that it was easily representable without confusing the diagram. So in terms of ontology coverage, I'd say there's definitely some gaps, certainly something that we can consider, and I'll sum up those a little later in the presentation. With regards to data model coverage, there are rather more noticeable gaps, I would say. As mentioned before, the high level representation of the materials ontologies it's really lacking. Sorry. All of them have very narrow focuses as to how they represent materials, and there's not really a consistent data model that works across them. So there's a very large gap, I would say, in representing materials. In terms of experiments, we're aware of a Pistoia effort, the SEED project, which I think stands for Semantically Enabled Electronic Database or something along those lines. I believe there may be a presentation or talk about that later in the Allotrope Connect. So I will defer to that or to some of our Pistoia colleagues who can probably give more detail than that. But as that's at a relatively early stage, again, there's relatively light coverage in that domain at the present time. In terms of processing equipment, as you can see, we weren't able to identify any data models that really covered that, which fits with the fact that there were very limited ontological coverage in that space. And then analytical instruments and results, again, that's where Allotrope has had its main focus for the last few years. So we cover the domain fairly well, both in depth and breadth of coverage. Technique-specific models, of course, will go deeper, but have a very narrow focus to their specific techniques. Lastly, there are a couple of efforts in the instrument control space that we're aware of. One is the OPCUA's Spectaris or LADS effort, which will actually form the backdrop of our keynote speech tomorrow. The other is the SILA consortium working on instrument control via SILA. I believe SILA 2 is the latest version there. Both of those efforts are out there intending on focusing on instrument control. Neither of them sort of mandates a particular ontology for use, although as I understand it, Spectaris has some semantic support. It doesn't leverage it directly or as a sort of a core requirement, which is why there's limited coverage in the ontology space and more in the data model space. So hopefully the diagrams make sense in terms of the overall landscape. In terms of the gaps we've identified as potential directions that Allotrope could take and try and fill, the high-level unifying model for materials seems that it could be something that's quite valuable, although the ontologies exist. As I said, they tend to have very specific focus, and there's opportunity for harmonization there, particularly in the data model space, but also in the ontology space. Processing equipment, there's really not much coverage there in either respect. That's a potential gap, and in particular, as that would tend more towards the development space, that could help encourage standardization both in the general and in the specifically using allotrope sense if we were to look at filling that gap in processing equipment to move into more development efforts. I mentioned the Pistoia Seed project, which is standardizing models for ELN use cases, but those existing ontologies that exist that we reviewed are either not BFO aligned or maybe don't cover the domain that well. It's something that we could consider looking to collaborate with them on to see if there's a sensible approach that we can take that benefits both organizations and by extending AFO into that domain, or even just suggesting what would be needed to extend the existing ontologies in a way that aligns well with BFO and allotrope ontologies in future. And last but not least, of course, the control of instruments. We identified the two efforts on the data model side, but not really much in the way of the public ontology control. So that's certainly a potential useful effort, particularly in the context of the OPC-UA effort with Spectaris and LADS, because they already have semantic capability. And as I said, that will be displayed, I think, in tomorrow's keynote speech from Matthias. So those are the gaps we identified. The question is, what do you need? In terms of our Allotrope roadmap, we would very much like to take the community's needs into account when planning for this. So if your organization has an interest, has a need in any of these gaps that we've identified, or any others that you've identified that we missed, or that were outside of this scope but you feel are very important, please reach out to the product team, let us know your priorities. We can have a discussion and see if that's something we can factor into our roadmap for the future. Of course, you can also attend our weekly modeling working group meetings. If you want to have a more direct hand in shaping the modeling efforts, that tends to influence not only the data models, but also the ontologies by creating the terms for those data models. If you're interested in either or both, please reach out to the product team, to Amnon, to myself, and we'll be very happy to set up some time to discuss or to send you the invite to the group. So with that, that's everything from me, I think. If there are any questions, if we have time, or if not, we can slide on to the next talk.
Great, thank you, Ben.